And without further ado, the next speaker is Mehrdad, and he's going to be speaking about imbalanced data. Let's give a round of applause for Mehrdad.
Awesome, thanks. Thanks for everyone for coming. So we're going to talk about imbalanced data, a hot topic in machine learning. And so this is actually part of a much longer talk that I gave in San Diego, part of the open machine learning, et cetera, meetup group. There's a meetup group there that meets about once a month, and they talk about open source projects. I just moved here from San Diego maybe a couple of months ago, and so I'm just thought this would be a relevant talk, so thanks for the last minute addition. So there's a lot of material here, but I'm going to just go over them as fast as I can. And I'm not going to talk fast, I'm just going to skip it, and then if you're interested, you can check out these links for the relevant stuff. So I'll give an overview of the machine learning landscape and the particular challenge with imbalanced data. Then I'll talk about these, what I would like to call data mining hacks. And quite often, machine learning and data mining and data science are used interchangeably because there's a lot of overlap between these fields. But I think in this case, these particular techniques, the term data mining in particular is very appropriate. And then I'll gloss over some machine learning ideas that can be used for dealing with machine learning, with imbalanced data. All right, but before that, I have to give my shameless announcements and advertisements. Right, I was told that meetups are all about advertising, so here's my contact info and stuff if you want to reach out to me. And also, I think newsletters are back again. Everyone's signing up for a newsletter, so I've started a newsletter, and if you're interested in hearing about my war stories in machine learning, and both from a research academic perspective and a kind of practical industry perspective, just basically, water cooler conversation talks that I have with people, and sharing some knowledge there. So, by the way, these slides are shared, and I think I just posted them on my Twitter handle. So if you want to just grab them, you can do that. All right, so let's just start with the main stuff. So machine learning, I think, is just basically curve fitting. That's the most popular and most successful branch of machine learning, is essentially finding how to fit curves. And this particular type of problem is called classification. And really, the types of curves you're trying to find are curves that separate out different dots on the graph, right? That's basically all that it boils down to, right? So machine learning is just over-glorified curve fitting. And everyone has their own favorite camp of curve fitting function, right? Some people like neural networks, some people like multinomial Bayes rule or whatever. And what's nice is that Scikit-learn, open source Scikit-learn package, gives you access to all these different tools with a common unified API. So that's really cool and awesome, and this is sort of a high-level overview of how to use Scikit-learn. If you haven't seen it before, you just basically instantiate a model, right? So this is a linear regression model. Then you have this fit method that fits your data. You pass it 2 NumPy arrays, and then you do some prediction on that, right? And that's basically a handful. You just have to learn a handful of methods, and you're on your way to doing machine learning, right? So that's all great, but then there's, of course, in real-world data, quite often we'll face this issue of having imbalanced data. So we had a talk earlier on healthcare, which I thought was really cool, and healthcare in particular is a great example of having imbalanced data. Quite often you have very rare diseases, right? You have very rare instances of something you're looking for, so it's a really hard finding a needle in a haystack type problem. I did a lot of this work when I was in Symantec in San Diego, part of a company called ID Analytics, where they were interested in fraud. And fraud is another very famous kind of example of trying to dealing with imbalanced data, right? So if this is an example of using kind of off-the-shelf Scikit-learn to classify between 3 different classes, you'll notice that the decision boundary is really only cares about 2 classes. It misses out on this purple class. Right? But then if you use some of these data mining tricks from this Imbalanced-learn library that I'll talk about, then that'll fix the problem. All right, so I'll talk about these data mining hacks really quick, and I think the term data mining is appropriate because they're not, so machine learning, in my opinion, machine learning is a learning problem, right? You're trying to design algorithms that learn from data, whereas these methods, they're really trying to, you're not messing with the learning algorithm. The learning algorithm is as it is, you're messing with the underlying data, right? So you're just hacking the data and then keeping the learning algorithms fixed. So that's the high-level idea of these types of techniques. There's a super popular and easy thing if you don't want to deal with, if you don't want to learn anything, right? You just love using Scikit-learn and you don't want to learn anything, then there's this awesome a flag in pretty much all Scikit-learn classifiers called class weight. And essentially, if you just blindly set it to balanced, quite often it'll do better than just not doing anything at all, right? And if you subscribe to Andrew Ng's stuff, he also has a mailing list, right? So he has this mailing list where he sends out his chapters on his new book, and he talks about how to deal with this issue, and he exactly cites this same thing, right? So it's a great method on how to deal with imbalanced data. But in industry, we also do a lot of other tricks, and that's what I think this Imbalanced-learn package does really well. This is an extension to Scikit-learn. It's part of the contributor libraries. So it follows a very similar API to Scikit-learn. The other, I think, really important issue is that it extends Scikit-learn's pipeline class. So if you're familiar with Scikit-learn pipelines, this is an extension of that. So it's able to, so you're not, you're preventing data leakage. So that's what's really nice about this package. So some popular things you could do that people do this in the industry, I won't say which ones. Basically, you just randomly oversample the minority class, right? So you have a minority class, like let's say the purple class, and you just do multiple duplicates. So you just duplicate it like crazy until the number of examples in the minority class matches the majority class. So that's like a really, really easy trick. And it's actually, on average, on expectation, you can theoretically show it's equivalent to Andrew Ng's thing. Right? But in practice, quite often, that'll actually might give you some randomization, which will help you get some better results. On the flip side, you could also do randomly undersampling, right? So you could just randomly throw away a bunch of these yellow dots, and that actually kind of works, pretty good in practice too. Okay, so this is one algorithm that's very, very popular when people talk about imbalanced learning, and has this funny name, SMOTE, and it just stands for Synthetic Minority Oversampling Technique. And basically, the way it works is if you have this minority class, right, the blue class, and you randomly pick an anchor point, right? So this is like an anchor point xi, and you just draw this ball around it, and you try to find the nearest example that is from the same class, and then you just generally basically create fake data. You just take the combination between this dot, and that's your new data, right? So now you're creating new fake data to append your data set. All right, and so what that looks like is on the left, this is what the decision boundary looks like when you do that, right? So it actually does a pretty good job separating the purple class. And the reason it does that is because underneath the hood, you generate all this fake data, right? You generate all this little fake data that's just basically random combinations of these dots, and so that can influence your classifier decision boundaries, right? So the quick 101 on Imbalanced-learn. So it's very similar to Scikit-learn. You just basically instantiate a particular sampling technique. So in this case, let's say SMOTE, right? You just create this sampler, and then you have your vanilla old school Scikit-learn classifier, a linear support vector machine, and then what you do is you fit the sample, right? So what you do is you pass the imbalanced data set here, and you get back a balanced NumPy array that then you pass to your Scikit-learn classifier, right? So it's very, very easy, and I think what's really super important is that the pipeline class has been extended, right? And so now what this does is that you can do a resampling as part of your machine learning pipeline, right? So you could do your SMOTE sampling, then you apply PCA, then your classifier, and you're good to go without having to worry about leakage or anything like that. Okay? All right, so now that's just really quick whirlwind tour, and then this is some just high-level machine learning ideas on how to deal with this imbalanced data stuff, and there's 3 major branches to this, right? So I have 3 subsections here. So there's feature engineering, feature learning, and lots of ensembles. I'm gonna speed this up a little bit. I think we're short on time, and so basically, in the feature engineering sense, in this case, what we did was we basically just randomly combined all the data, right? But what you could do, and this is so Daniel mentioned what sort of projects are you working on. So this is one of the things that I'm working on that I'm trying to add to the Imbalanced-learn library. So if you're interested in working on this, let me know. I'd be happy to talk to you about it. And so I'm working on this thing called subset SMOTE, right? That instead of just naively combining all the features, you're only combining a subset of the features, right? And that subset of the features could either be randomly selected, which could be down the road used in a random ensemble of some sort, or it could be designed, selected by someone with domain expertise, right? So what that looks like is you'll get decision boundaries that look maybe a little better, and so there's lots more stuff about this. Just the feature, so this is, I believe this is actually a machine learning idea because we're actually learning features, right? So the idea of machine learning, one of the ideas in machine learning is we want to figure out what is the underlying data generation process, right? So there's this hypothesis that the data that we observe is there's actually a low dimensional manifold that is hidden from us, and what we'd like to do is learn this underlying data generation process, right? So deep learning and a lot of great machine learning methods try to figure that out, try to untangle what is the underlying low-dimensional manifold. And it turns out if you actually apply that, so this is an example of using kernel PCA, which is a type of shallow deep learning, that essentially you could see that if you untangle your original data set, right, which looks like this, kind of has a weird geometry, right? But then if you apply this kind of machine learning stuff, then the data has a much cleaner geometry and you can apply SMOTE or whatever you want. Okay? And so I have just one really last thing. So I talked a lot about randomization, right? Randomly sample this, randomly oversample, undersample, random this, that, etc. So this just lends itself nicely to bootstrap aggregation, right? Just ensembling lots and lots of different randomizations. And usually you can show that if you ensemble a bunch of classifiers, the variance of the whole thing goes down, and that's usually a good thing, right? So that is it. This is my algorithm. It's called BAS. Here's a data set I'm working on, and my algorithm does better than the rest, so. Okay, and that's it. All right, so thank you.
Wow, that was really, really great. You have any questions? Anyone? I saw a hand over there somewhere, or not? Well, there's one thing I wanted to tell you, which is I really appreciate how you actually get something like imbalanced data and explain in a very, very easy way. When I actually had to deal with a problem, I went completely insane, and I spent a lot of time before I figured it out.
Yes.
So had I seen this talk in the past, it would have saved me a lot of time and a lot of smashing my head against the wall. So thank you very much.
Well, thanks for the package, right? I mean, the package makes life a lot easier.
Yeah.
So those guys, did a great
yeah.
job. So,
and for whoever has this problem in the future, BAS is your solution. Sounds like that.
All right.
Thank you very much.